So let's take a look at your activity number 2, and so that will be your kidneys, okay? And so your anatomy and physiology of your kidneys, okay? So with that, you are required to draw the internal parts of your kidney, okay? And so in this, and so you have here on your screens, you have here an illustration of your kidney, okay? And so of course, you already know that kidney is a paired organ, okay? And so it's been shaped in yes, in shape, okay? And so with this, of course, you have here your internal parts of your kidney, okay? And so you have your renal cortex, your renal medulla, and so under that you have your renal column and then your renal pyramid, and then you have your renal papilla, your renal lobe. Then of course you have your fibrous capsule that encloses your kidney. Also under that you have your minor calyx, your major calyx, and then your renal pelvis. And so your major calyx will form your renal pelvis, and then you have here from your renal pelvis to your ureter. Okay. Of course, your ureter here is not part of your kidney, and so but then, and so it is still part of your urinary system. Okay, and so for your renal artery, and so of course, your renal artery, that is the uh entrance, no, and so that is the entry, and so that is the blood vessel that carries oxygenated blood, and of course your renal vein, and so that carries the filtered blood. Okay, and so with this, of course, your hilus, and so the area where you can see your blood vessels here, your renal artery and your renal vein, and so that is what you call as your hilus or hilum. Okay, again, your hilus, that is the area of attachment through which your blood vessels and the nerves pass into and out of the kidneys. Okay, and your renal artery again, and so that is the blood vessel through which the blood enters your kidney, and then your renal vein, and so that is the blood vessel through which blood leaves the kidney. Okay, and so your renal cortex here, and so your renal cortex, that is the outer layer of the kidney, and it is about 1.4 centimeters in thickness. Ayan, so that is 1.4 centimeters in thickness and serves as the exclusive site for plasma filtration. And so with that, of course, you have here your glomerulus is located in your renal cortex. Your renal medulla, and so that is the inner region, and so that has a stringy macroscopic appearance. Of course, with this, it contains your collecting ducts, and so that conveys urine to your renal papillae. Okay, and so your renal pyramids or your Malpighian pyramids actually, and so you have here they are any of your conical masses that project as renal papillae into your renal pelvis. And so they are actually this one's your renal pyramid. And then of course your renal lobe, and so that is your renal lobe, that is the overlying the cortex area for your renal lobe here. Okay, and so your calyces, your minor and major calyces, and so they are cup-like divisions of your renal pelvis surrounding one or more renal papillae. No, and so you have there, and then you have your pelvis. Your pelvis is a funnel-shaped structure that is formed at one end by the expanded upper portion of your ureter. And then, of course, you have your nephron. Your nephron, that is the functional unit of your kidney and is located mostly in your cortex area. And so, of course, each kidney, and so they have about 1 million to 1.5 million nephrons. And so, to give you an approximate of 3 million kidneys for for the paired organ. Okay, and so you have there for your internal parts of your kidney. So let's take a look at your renal at your nephron and its parts again. And so your nephron, that is the functional unit of your kidneys, and as what we said earlier, it is located mostly in the cortex. Okay, and so As what we stated in the lecture, and so you have your two types of nephron. You have your cortical and your juxtamedullary nephron. And so for your cortical, and so they comprise approximately of 85% of your total number of nephrons. And the primary function here is for filtration of your filtration of your blood. Okay, and so they are primarily located in the cortex and they function for tubular reabsorption and secretion. Okay, and so while for your juxtamedullary nephron, and so they have loops of Henle that extend into the medullary region, and they function for urine concentration. Okay, and so let's take a look at the parts of your nephron. And so of course, first you have your glomerulus or your capillary tuft, no? Your glomerulus, and so this is the filtering component of your nephron. Okay, and so of course with this it is a specialized capillary network that found at the blind end of a nephron. And of course, and so this one functions for filtration. Okay, and so again for filtration. And then you have here your Bowman's capsule. Ayan, so your Bowman's capsule, ayan, so it surrounds the glomerulus. And so it surrounds the glomerulus, and this one is continuous with your renal tubule. And so your Bowman's capsule. And so your Bowman's capsule. Okay, and so of course with that you have actually in your Bowman space, and so that is where you can find the ultrafiltrate. In your Bowman space, that is where you can find the ultrafiltrate. Okay, and so still part of your nephron in your renal corpuscle is your afferent arteriole. And so your afferent arteriole, and so it has actually a bigger lumen and carries blood to the glomerulus. And then your efferent arteriole, and so when your afferent arteriole will divide to form your glomerulus, and this capillaries will form, will converge again to form your efferent arteriole. And so with this, has a smaller lumen and carries blood from the glomerulus. Okay, and so your renal tubules, and so in your renal tubules, you have actually your proximal convoluted tubule, your loops of Henle, and then you have your distal convoluted tubule. Okay, and so for your proximal convoluted tubule, it has a convoluted portion. Ayan. So proximal, meaning it is closer to your uh to your glomerulus. Okay, and so it has a convoluted portion and a straight portion with which becomes the loop of Henle. And so once it reaches the medulla, and then your loop of Henle, and so you have here your thin descending segment no thick descending segment, and then a thin descending segment, and then you have here your U-shaped segment, and then you have a thin ascending and then a thick ascending segment. Okay, and so you have here, and so you have your U-shaped segment also here. And so of course with this, and then you have your distal convoluted tubule. And so for your distal convoluted tubule, it is composed of 2 to 3 loops and begins at the juxtaglomerular apparatus with your macula densa for your distal convoluted tubule. And your collecting duct, of course, and so it traverses the renal cortex and medulla, and then serves as the final site of final urine concentration as such. Okay, and so you have therefore your nephron. Okay, and so let's take a look at your renal blood flow. And so with this, and so of course your kidneys, and so the kidneys accordingly process approximately 180,000 ml. And so 180,000 ml of filtered plasma each day. And so to produce a final urine volume of 600 to 1,800 ml. And so again, And so, or this one, of course, it receives your, what you call this, your urine receives a 25% of your cardiac output. And so your kidneys approximately receive 25% of your cardiac output. Okay. And so of course, accordingly, your kidneys and so directly affects your renal blood flow, sorry, and so directly affects the kidneys functional ability. And so of course your kidneys and so require rich blood supply to perform its primary function, which is to regulate your body's internal environment. Okay, and so when there is a decrease in blood pressure, and so you have here your afferent, and so afferent arterioles will dilate to prevent decrease in renal blood flow. And so with this, when there is a decrease in renal blood flow, it will lead accordingly to build up of metabolic waste. While in case of an increase in blood pressure, your afferent arterioles will constrict to prevent increase in renal blood flow, which will lead to overfiltration and glomerular damage. Again, and so when there is an increase in blood pressure, your afferent arterioles will constrict to prevent increase in renal blood flow, which will lead to overfiltration of your glomerular damage. And so for your renal blood flow, and so of course it will start, and so your renal artery, and so it carries blood to your kidneys. And so it will start from your renal artery, and so to it will go the blood will go into your segmental artery, to your interlobar artery, and then to your arcuate arteries, to your interlobular artery, to your afferent arteriole. And so that is already part of your renal corpuscle. And then your glomerulus, and so your glomerulus here is a capillary tuft. And so it is eight. And so eight capillaries. And so tuft of eight capillaries. And then your glomerulus will form into artery again. And so that is called as your efferent arterioles. And your efferent arterioles will, what you call this, will subdivide to form your capillaries. And so you have there your peritubular capillaries and your vasaric. And then with this, and so you have your interlobular vein, to your arcuate vein, to your interlobar vein, then to your finally to your renal artery. And so with this, of course, and so your renal artery, and so in this one, I mean your renal artery, and so uh you have here your oxygenated blood, and so that will enter, and the unfiltered blood. And so in your renal artery you have your oxygenated and unfiltered blood, and then in your renal vein you have a filtered blood. And so you already have a relatively clean one. Okay, and so that is for your renal blood flow. Okay, and so with that, for your renal vein, and so it drains your blood from the kidneys, your afferent arterioles, and so it will carry blood to the glomerulus. Your efferent arterioles, it will drain blood from the glomerulus. And then your peritubular capillaries here, and so you have a capillary bed that surrounds your convoluted tubules, while your vasa recta, a capillaries that surrounds the loop of Henle. Okay, and so you have there, and so for your total renal blood flow, and so you have it at 1,200 ml per minute. And so to 1,200 ml per minute. Okay, and then for your total renal plasma flow, you have it at 600 to 700 ml per minute. Okay, and so you have there. Okay, moving on. Okay. Let's take a look at your urine formation. And so your urine formation actually is the primary excretory function of your kidneys. And so of course in your urine formation you have your uh, three processes that is involved. And so first one of course is your plasma filtration. in your glomerulus. And so you have your glomerular filtration of plasma, followed by reabsorption and secretion of selective components of your renal tubules. And so, of course, through these processes, and so your kidneys accordingly play an important role in the removal of waste products. Other than that, regulation of water and electrolytes, like your sodium and chloride, and of course maintenance of your acid base balance. And so we already talked about this one in the lecture. And so the kidneys, and so they are accordingly true regulators of the body, and so determining which substances to retain and which is to excrete, and so regardless of what has been ingested or accordingly produced. And so with this, and so again, and so it involves your three main steps. You have your glomerular filtration, followed by tubular reabsorption, and then tubular secretion. Okay, and so in your glomerular filtration, you have what you call this as your net filtration pressure. And so your net filtration pressure here, and so uh it favors your filtration of your plasma. Okay, and so your net filtration pressure is at 10 millimeters of mercury. Okay, and so we already talk about your uh, glomerular hydrostatic pressure and then blood colloid hydrostatic pressure in the lecture. And so with this, other than your net filtration pressure that will favor filtration, you also have your requirement here, and so you have a requirement for your substances to be filtered out is at least less than 70,000 daltons, and so less than 70,000 daltons, and you have at least a negative or neutral charge to pass through your shield of negativity. And so to pass through your shield of negativity accordingly. And so again, during your glomerular filtration, you have here your blood will enter the afferent arteriole and flows into the glomerulus, where of course your filterable blood components like water and waste move toward the inside of your glomerulus. Okay, and so they will move to your Bowman's space. Okay, and so they will move to your Bowman's space. And of course, the non-filterable ones like your cells, your proteins, and so they will remain inside your capillaries and of course will exit into your efferent arterioles. Okay, and so into your efferent arterioles. Of course, the filterable components will accumulate in the glomerulus and so to form a glomerular filtrate as such. And so in that is in your Bowman space or in your capsular space. Okay, and so followed by, of course, you have your tubular reabsorption. In your tubular reabsorption, that is actually the movement of substances from the tubular fluid back into the blood. And so what are you trying to reabsorb here is the essential substances. Okay, and so the essential substances. And so in your reabsorption, and so molecules and ions are reabsorbed into the into the circulation. Okay, and so of course the fluid will pass, and so through the components of the nephron, you have there your distal convoluted your proximal and distal convoluted tubules together with your loop of Henle and the collecting duct. And so with this, and so you have here again, and so your components, the fluid will pass through your components of your nephron, and your water and ions accordingly are removed as the fluid osmolarity will change in such. Okay, and so you have here, you already have here your capillary beds, you have your vasa recta and your peritubular capillaries, and so that are also important in your tubular reabsorption here. And then you have your finally you have your secretion. Okay, and so under your tubular reabsorption, you have there your concentrating ability, your tubular concentration also. And so, but then as such, in your tubular secretion, you have here your your this is the movement of substance from the blood into the tubular fluid, and so you secrete, and so you secrete those that needed to be excreted, and so you have there, if you have reabsorption, as you are taking in the essential substances, and so for your secretion you are secreting, and so those that are not important, the non-essential ones. Okay, and so with this it involves your transfer of your hydrogen, your creatinine, your drugs, your urea. And so from the blood into the collecting duct, no? And so from the blood to the collecting duct, and so from the blood to your proximal convoluted tubule, to your distal convoluted tubule, and then to your collecting duct. And so, and of course, Ayan, so of course with this, your blood and glucose are not normally found in the urine. And so they are not normally found in the urine, okay? And so for your process of urine formation, and so when the fluid is in the collecting duct, and so that is the time that you can call it as urine. Okay, and so when the fluid is still in your Bowman space, and so you call it as ultrafiltrate still. Okay, and note that your urine is an ultrafiltrate of plasma. And so ulit, and so for your urine formation, it involves three steps. And so you have your glomerular filtration. And so what are the requirements here? And so you have a less than 70,000 daltons of molecular weight, a negative charge or neutral charge, and of course you have here your your net filtration pressure, and then your tubular reabsorption and your tubular secretion, and so which involves of course your active and passive transports, and so passive transport of water and active transports of other substances as such. Okay, and so you have there, and so suppose you have here, and so in your glomerular filtration you have a fluid, the specific gravity of the fluid in your glomerular filtration, in your glomerular filtrate is 1.010. And so when it will go into your, when it will leave your, what you call this, your collecting duct, and so probably, and so it is somewhat, the concentration is somewhat altered, and so then the specific gravity should be greater than your the greater than the fluid in the Bowman's space, and so allotting to the concentrating ability of your tubules. Okay, so let's take a look at your renal threshold and and maximal reabsorptive capacity. And so your renal threshold here, and so is the plasma concentration of a substance at which it begins to appear in the urine. And so below this threshold, the substance is completely reabsorbed. Okay, and so the substance is completely reabsorbed by the renal tubules. But then, and so when the plasma concentration of the substance exceeds the renal threshold, the tubular reabsorptive mechanism becomes saturated. And of course, when there is an excess, and so when there is an increased amount, when there is the exceeding concentration present in the plasma, and so will start to be excreted in the urine. Okay, and so you have there, let's say for example, and so you have here your glucose, and so the renal threshold is 160 to 180 milligrams per dl. And so let's take the upper limit, the 180. And so when the glucose value is 190, and so then of course it exceeded, then you will already see glucose in the urine, and so it is not anymore Yan, yes, it is already, you can already see it in the urine. And so your maximal reabsorptive capacity refers to the maximum rate of reabsorption of a solute by the tubular cells. Okay, and so it is the maximum rate of a substance that the renal tubules can reabsorb from the glomerular filtrate back into bloodstream. And so per unit of time accordingly. And so this maximal reabsorptive capacity accordingly is limited by the number of transport carriers or channels available in the renal tubules for a specific substance. Okay, and so the relationship of your renal threshold in maximum reabsorptive capacity, and so the relationship, I mean, they are actually related. And so you have here. And so uh, your renal threshold represents the point at which your maximal reabsorptive capacity is reached for a particular substance. And so before accordingly reaching the threshold, the kidneys effectively reabsorb substances. And so if still, and so let's take a look, for example, and so a plasma concentrations of 100 milligrams per dl. And so there is an effective reabsorption of substance. And so thereby, there is no excretion in the urine. And so you cannot see. And so when the plasma level is 100 milligrams per dl, then there is no excretion of glucose in the urine. Then you cannot see urine in the you cannot see glucose in the urine. Okay, and so but then once the renal threshold is surpassed, and so you have here's the excess substance cannot be completely reabsorbed, and so there is no reabsorption already that will take place, and so leading to its appearance in the urine. Okay, and so it will lead to the again, and so let's utilize your glucose, and so the renal threshold for glucose is 160 to 180 milligrams per dl. Okay, and so under normal circumstances, and so let's say you have 100 milligrams per dl, all filtered glucose is reabsorbed. And so they will return in the circulation. And of course, they will return in the circulation, wala pong matitira sa filtrate. Wala pong matitira since you have it at normal. Ayan, so you have there. But then, and so when the plasma glucose concentration exceeds, and so the renal threshold, again, let's take the upper limit here. And so if it will exceed the 180 milligrams per dl greater than that, again, let's take a look. Let's say 190 milligrams per dl is present in the plasma. 190 milligrams per dl is the concentration uh, of what they call this of glucose in the plasma, then the maximal reabsorptive capacity for glucose is exceeded. And so there is no reabsorption already that will take place. And so what will happen to the excess glucose? And so they will remain in the filtrate. And so they will remain in the filtrate until excretion. And so that is why until excretion, and then you can see it in the urine. And so when there is an increased amount, then it will give you a positive reagent strip for glucose. And so that is an example for your for your uh, renal threshold of glucose. Again, and so in what they call this, when you have your renal absorption, I mean in your maximal reabsorptive capacity. And so let's take a look again at an example of your glucose. And so under normal conditions, and so let's say your blood glucose levels is less than 160 milligrams per dl. And so with that, all uh, remember that your glucose is it is filtered out. It is filtered in the glomerulus. And so, but then reabsorption will take place because you need glucose. Glucose is reabsorbed. Okay, and so all of your glucose is reabsorbed. That is for normal. Thereby, there is no residual glucose that will be left in the urine. But then, when there is an excess glucose, let's say for example, you exceeded the upper limit of normal, you reach 190 milligrams per dl. And so with that, your maximal reabsorptive capacity for glucose is exceeded. And so what will happen to the excess? And so they will stay in the filtrate, and they will not return to the circulation. And so what will happen, of course, they will be excreted in the urine. And when you will test the urine using a reagent strip for glucose, or when you test it with a glucose test, and so you will have a positive urine test. And so of course it will appear in your urine. Okay, and so with that, that is for your renal threshold and your maximal reabsorptive capacity. Okay, moving on to your tubular reabsorption and tubular secretion. Your tubular reabsorption, and so you have here your essential substances are returned to the circulation. Okay, and so your substances are transported from the filtrate back to the blood. And so still, and so it utilizes your passive diffusion, your active transport, and osmosis as part of it. Okay, and so of course with this, and so it will follow your concentration gradient. And so for your passive diffusion, and so some substances like water and lipid-soluble molecules will passively diffuse to your lipid bilayer of your tubular cells, no? And so of course when you say active transport, and so it uses mechanisms like, it uses energy. Okay, and so as such, and then for your osmosis, of course, and so it will follow your concentration gradient still. And so please refer to the table presented in the previous slide for the substances that are being passively reabsorbed and actively reabsorbed here. Okay, and so you have here, and then your tubular secretion. And so tubular secretion, of course, the process of the movement of substances from the blood in the renal capillary beds to the filtrate in the tubular lumen. And so your secretion of your metabolic waste products by renal tubular cells. Again, those that you do not need. And so with this, of course, it serves two functions. And so for elimination of waste products and for acid-base balance. And so of course you have here, you also have your active and passive transports that will take place here. And so you have there. Of course, for your active transport, you have your ions, your organic acids, and then for your passive diffusion, you have your drugs and the rest. And then of course your hydrogen ion secretion. Ayan, so they are these are actually important in what they call this regulation of blood pH. Okay, and so let's take a look at your tubular secretion. And so you have here your proximal convoluted tubule, and so hydrogen, ammonia, weak acid and acids and bases are secreted. And in your loop of Henle, you have urea. In your distal convoluted tubule, you have hydrogen, ammonia, potassium, uric acid. And then in your collecting tubule, you have your hydrogen ions, and the rest are being secreted. Okay, and so that is for your activity 2.